In this video, we are going to talk about basic logarithmic properties. These are very basic and very obvious, and these don't really require you to memorize them because they are very straightforward. However, it is good to know these properties because if you ever see them, you shouldn't even have to think about them. But the good news is if for some reason you do forget it, these should make sense. So the first basic logarithmic property, these are going to be the basic properties. So there are three basic logarithmic properties that when you see them, you need to know them without even thinking. So the first one is log base b of b. This is equal to 1. Remember, what you're solving for in a logarithm is the exponent. So any base raised to 1 will always be the base. So for example, log base 5 of 5 will always be 1 because 5 raised to the 1 is 5. So it doesn't matter what the base is. The exponent will always be 1 or if you get the log of the same base, of its matching base. The second property is log base b of 1. This will always be equal to 0. This is because any number raised to 0 will always be 1. Always. Does not matter what the base is. If it is raised to 0, it will always be equal to 1. So take, for example, log base 7 of 1. See? 7 raised to the 0 is 1. So it does not matter what the base is. Log base b of 1 will always be equal to 0. And the last important basic property is log base b of any number that is less than or equal to 0. This is because there is no such an exponent that will ever make the answer equal to 0 or a negative number. This will never be solvable, therefore this is undefined. For example, for proof, log base 2 of 0, what in the world would this be equal to? We'll see 2 raised to what is equal to 0. This is an impossible statement. There is no such an exponent that will ever make this equal to 0. Once again, like we said up here, if the exponent was 0, this would be equal to 1, not equal to 0. So this is impossible to happen. Another example would be log base 2 of negative 2. What in the world would this be equal to? So again, 2 raised to what is equal to negative 2. There is no such an exponent that will ever make this happen. You may get this confused with maybe raising this to the negative 1. But 2 raised to the negative 1 is 1 over 2. Therefore, this is incorrect. So there is no such an exponent that would ever make this base equal to a negative number or 0. It is impossible. Therefore, take some time in really understanding these basic properties and committing them to memory. But once again, they are pretty straightforward to understand. Now let's talk about the inverse properties. So there's only 2 of them. Now what you need to understand is a logarithm is actually the inverse of an exponent. And a logarithm is actually an operation, just like an exponent is. Now, you've always learned since elementary school the inverse operations. So you've learned the inverse of addition is subtraction. The inverse of multiplication is division. But you never learned what is the inverse of an exponent. And the inverse of an exponent is a logarithm. Now you may be thinking to yourself, wait, wouldn't the inverse of an exponent be a radical? No, but it would not be. So for example, x raised to the 2 is equal to 4, for example. So you're trying to figure out what does that x have to be equal to? Well, I can get rid of the exponent by getting a root. And yes, although that is correct, a radical or a root is really another exponent. So see, a radical doing square root on both sides, this is the same thing as saying raised to the 1/2. So therefore, a radical or a root is not an inverse of an exponent because it is an exponent. So the inverse operation of an exponent is a logarithm. Okay? So just like we've learned before, if you have x plus 2, the inverse operation is minus 2, therefore it undoes itself. If you add 2 and then subtract 2, you are right back to x. And you see, you could write this in the other order as well. You could have subtracted 2 first and then added 2. Again, you'd go right back to x. They undo each other. Same thing with multiplication and division. If you had x times 2 and then divided by 2, you literally just undid it and you are right back to x. And like before, if you were to undo the order, or reverse the order, and you divide by 2 and then multiply by 2, again, you undo the work and you go right back to x. The same thing occurs with logarithms and exponents. So the first inverse property is log base b of b raised to the x. This is equal to x. This is the first inverse property. Because notice what happens here is here you are raising the base to x, but then you're solving for the exponent, which is x. Therefore, you literally did opposite operations. So take, for example, let's do this here. Let's take, for example, log base 5 of 5 raised to the 2. Well, 5 raised to the 2 is 25. But log base 5 of 25 is 2. Because what exponent do I need to raise 5 to be equal to 25? That is 2. They undo each other. Here, again, you know the exponent is 2, therefore you plug in the exponent, but then you want to solve for the exponent, which is 2. So it undoes itself. Now, just like with the other properties that we saw that we can flip the order, we can also flip the order here. So if instead we wrote it like this, b raised to the log base b of x, this is equal to x. Once again, these are inverse operations. Here you're solving for the exponent I need to raise b to be equal to x, and then I'm plugging that exponent right back in. I'm raising b to that exponent, and that takes me right back to x. So take, for example, this problem. 2 raised to the log base 2 of 8. You see here, log base 2 of 8 is 3. Here I solve for the exponent. So what do I have to raise 2 to so that it's equal to 8? And that is 3, because 2 cubed is 8. So we find out that this is 3. So 2 raised to the 3, this is equal to 8. You see, they undo each other because they are opposite operations. They are inverse operations. And that is very important to understand. So if these share the same base and you're plugging in an exponential into a logarithm, or you're plugging in a logarithm into an exponential, and they have the same base, they undo each other. They're inverse operations. Therefore, these two inverse properties exist. Now, the last two, these are not essentially properties, but these are specific notations that we use for two special cases of logarithms. The first one is called the common log. Now, you may see here, and you may see this a lot, especially on a calculator, you will see this notation, log x. Now, at first glance, you take a look at this and you're like, wait a second, Doesn't a log have to have a base? And yes, that is true. But there is one specific case of logarithms where you do not have to put the base, because the base is always known. If you do not show the base, that means that this is actually base 10. So this here is the same thing as saying log base 10 of x, but nobody writes base 10. Instead, you just exclude writing the base 10. Just like with square roots, you don't really write down the 2 when you do the square root. But for all other roots, you have to put the number. Same thing for logs. For the common log, it's base 10, but you don't need to show the 10. The other type of log that we use is called the natural log. Now this notation, again, you have seen this in your calculator, and you probably have wondering what in the world does this mean. But this is ln. If you see ln, this is a very special notation. This notation is reserved only for a specific type of base, and that base is base e. So here, when you see ln of x, this is the same exact thing as saying log base e of x. But once again, you do not write base e. Instead, you rewrite the logarithm as ln, and that represents ln of x. So these properties and special notations also need to be understood fully in order to be able to solve any logarithmic problem that may be thrown at you. So take some time into memorizing these properties and notations. Once again, don't need to put too much time into memorizing. Hopefully these do make sense to you, especially the more you practice. Okay, take a minute to solve these following logarithmic problems. These all require the properties that we have seen before in this video. So take a couple minutes to figure these out. Pause this video, and in 5 seconds, I will show the answers. And here are the answers. And hopefully this video helped you in understanding the basic properties and notations.